Hi, continuation of contour integration. See, contour integration means certain real integrals can be evaluated using complex integration technique. Actually, the closed curve using complex integration technique, that is contour integration. So, we have totally three type. Type 1 already completed. It is a unit circle. So, type 1 already completed. So for the type 1, again the revision, you have to take z is e power I theta, d theta is nothing but dz by iz, cos theta is z square plus 1 by 2z, sin theta is z square minus 1 by 2zi. So next one is type 2. So type 2, always you have to consider minus infinity to infinity f of x dx. It is a semicircle, semi-contour, right? Semicircle contour. So always, which are the values lies inside, which are the poles lies inside means all positive i's lies inside, negative I lies outside. So this is lies outside. All positive I lies inside except infinity, right? All positive I lies inside and all negative i's lies outside. So for type 3, the same concept, but the limit must be integral minus infinity to infinity. Type 3 also integral minus infinity to infinity. The difference is the function in terms of sin x and cos x. So how to convert this? You know e power I theta, how to write e power I theta as nothing but cos theta plus I sin theta, right? So cos theta is nothing but the real part of this. Once I want to write cos theta means I can write real part of e power I theta. That's what here given. Cos x is nothing but real part of e power ix. Sin theta is nothing but imaginary part of this, right? Imaginary part of right hand side. So imaginary part of e to the power I theta. So similarly for sin theta, sin x you have imaginary part of e power ix. So for this type 3 also semi-contour, right? So type 3 also semicircle contour. All positive I lies inside, negative I lies outside. So this is all positive I lies inside, all negative I lies outside except infinity. This thing you know. So let's start the first problem. Evaluate. So they will not give you use contour integration, that's and all. Only the word they'll give you evaluate. You have to identify all the three types. So this is only in terms of x. That's what it is, type 2. The limit also very exact limit. It's a semicircle minus infinity to plus infinity, 1 by x square plus 1, x square plus 4 into dx. The very first step you have to write f of z. The inner function is f of z. Nothing, you have to replace x by z. What you need to do? Replace x by z. So f of z is nothing but this one, z square plus 1, z square plus 4. So immediate the next step to find the poles. To find the poles, always denominator equal to 0. The denominator is this thing, right, equal to 0. For simplifying this, doing factorization, z square equal to minus 1, here z square equal to minus 4. Square root of this, you will get z equal to plus or minus, z equal to plus or minus 2i. So you know all positive I lies inside. You know all positive I lies inside. All negative I lies outside means always residue 0. Lies outside, residue 0. No need to calculate the residue, right? Now we are going to calculate each and every residue. For this, we need to calculate two residue. The first residue, limit z tends to I. Formula, limit z tends to a, z minus a, f of z. A is I, right? Limit z tends to I, z minus I, your f of z is this thing. So how you get this z minus I? Solving this, right? Factor of this. So that's what you have to write. This z square plus 1, I can write z plus I, z minus I. Compulsory for finding residue, you have to cancel the term numerator as well as denominator. So that's what doing factorization, z plus I, z minus I. So z minus I getting cancelled and substitute limit. So z tends to I. So wherever z, you have to substitute I. So this will be 2I. This term will be 2I. This term will be I square. I square means it is negative 1. Minus 1 plus 4. Plus 4 minus 1, it is plus 3. So therefore, the answer 3 2s are 6i. The first residue 1 by 6i. So second residue formula also, the order is 1, right? The order is 1. Why I am saying the order is 1? The power. This is inside power, the whole power 1. That's what order 1. If order 1 means the residue formula, this is the formula. Limit z tends to a, z minus a, f of z. A is here 2i. So limit z tends to 2i, z minus 2i, f of z. And how you got z minus 2i? Factor of this. And write this factor, z plus 2i, z minus 2i. So this z minus 2i getting cancelled, right? And limit tends to, z tends to 2i. Wherever is it, you just substitute 2i. So here you will get 2i the whole square. Here also 2i plus 2i, it is 4i. 2i the whole square means it is 4, I square is negative, right? Negative 4 plus 1. So this would be minus 3. Minus 3 into 4, it is minus 12i. So you got the residue, second residue also. By Cauchy residues theorem, the problem minus infinity to infinity, the given problem is 2 pi I into sum of the residue. The first residue is 1 by 6i, the second residue is minus 1 by 12i. Simplifying this, you are getting pi by 6 is the answer, right? So this is residue calculation, semi contour, right? Semicircle. The same way we'll go for the next problem. See, always semicircle also, the limit must be minus infinity to plus infinity. Here you have 0 to infinity. So you know the definite integral concept, integral minus a to plus a, you can write 2 times 0 to a. So you have to bring the 2 in the denominator, 1 by 2. So instead of 0 to a, I can write 1 by 2 minus a to plus a. The same concept, instead of 0 to infinity, I can write 1 by 2 minus infinity to plus infinity. Now the function is semicircle, right? So the concept, now write f of z. F of z is numerator 1 by 2. Just replace z by x by z. Just replace x by z, that is your f of z, just replace. So 1 plus z square the whole square. How to find poles? Denominator equal to 0. So 1 plus z square equal to 0, the power is 2, don't forget. 1 plus z square equal to 0, z square equal to minus 1, z equal to plus or minus I. So the order is above, the order is 2, the poles are z equal to I, z equal to minus I. Always negative I lies outside, residue 0, positive I only lies inside. Because it is a semicircle, right? All positive value lies inside, all negative I lies outside. So this is lies inside, this is lies outside, right? For lies inside, you have to find a formula. It's very important formula. The order is 2. If the order is 1, you know limit z tends to a, z minus a, f of z, right? Limit z tends to a, z minus. The order is 1. If the order is 1, this is the formula. Till now we are solving this. If the order is 2 and above, the formula is 1 by m minus 1 factorial, d power m minus 1, dz to the power m minus 1, z minus a whole power m into f of z. The value of m is here 2. So 1 by 2 minus 1 factorial is 1 by 1 factorial, 2 minus 1 is 1. So d by dz of z minus whole power 2, f of z is 1 by 2. So already you know, right? The f of z is 1 by 2, 1 plus z square the whole square, right? That's what I have written here, right? So next step, this is the step. So how you are getting this factor? By how you are getting z minus I? By solving this, you will the factor of this. So z plus I the whole square. What is the factor? While solving this, what you got? Plus I minus I. So that's what you have to write. Z plus I the whole square, z minus I the whole square. This compulsory you have to cancel. So 1 by 2, take 1 by 2 out. Limit z tends to I, d by dz of 1 by z plus I whole square. See, always follow inner function followed by outer function. The inner function is now differentiation. The outer function is taking limit, right? First do the differentiation of this function. So you know 1 by x to the power q. The formula is minus q by x to the power q plus 1, right? The differentiation formula. Recall the differentiation formula. So the power is 2. So minus 2 by z plus I whole power 2q plus 1. 2 plus 1. It is 3. So the differentiation of this is minus 2 by z plus I the whole cube. And now apply the limit. First inner function differentiation completed, followed by applying the limit. Wherever z is there, substitute I. So it is 2i whole cube. I cube means I square into I. I square is negative 1. So negative into positive, so negative I. So the denominator 2 cube is 8. So negative negative getting cancelled. This 2 also getting cancelled. Then the answer is 1 by hi for the residue. By Cauchy residues theorem, 2 pi I into sum of the residue, that is 1 by hi. I getting cancelled, and I am cancelling this 8 also. So the answer is pi by 4. Right? This is the second problem. So the thing is, the limit must be minus infinity plus infinity. Otherwise, you just do arrangement using definite integral model. So next, this is the next type, that is type 3. Type 3, the same function including cos x sin x. So already we discussed, cos x means it is real part of e power ix. Sin x means imaginary part of e power ix. First write that. After that, take the denominator. Finding poles, denominator equal to 0, you are getting the same semicircle here also. Z square equal to minus 1, Z equal to plus or minus I. All positive I lies inside, all negative I lies outside. Right? Lies inside, and the power is 1. So residue Z equal to I, limit Z tends to A, Z minus A, f of Z. F of Z is this, and factor of this is Z plus I into Z minus I, cancelling this, and substitute Z equal to I into I square will come. E power I square is e power minus 1. Here I plus I, it is denominator 2I. So the residue is this. By Cauchy residues theorem, real part, because cos x we have, real part of 2 pi I sum of the residues. So sum of the residues is e power minus 1 by 1. I getting cancelled, this 2 also getting cancelled. Already it is a real part. That's what you can write separately, pi e to the power minus 1. I can write pi by e. So this is the answer. So similarly, why don't you try in terms of sin x, x sin x. So the answer for this problem is pi e power minus 2 by 2. Please try, then you will get the answer. Okay. Thank you.